Greetings and welcome back to Room 303 in Freshman English. We are in the middle of a poetry unit, number 4 in your hymnal. We're on page, however, 742, 743 and following. Now, in the middle of this unit, your textbook company wants to remind you that there's more than poetry that we need to be able to read as freshmen. Reading for information is also really important. Hey, you've already heard from me a number of times. We have to take tests in our freshman year. And much of that testing, that standardized testing, has to do with your ability to read for information, as we call it, informational or expository texts. And I think I've already said to you before what I'll say again, and that is this. In your academic career, you'll spend more time reading stuff like the stuff we're about to work through than you'll ever spend reading poetry or short stories. For example, every university class you'll take will have a required textbook. So, for example, even if you take a university class on how to write poetry, you're still going to have a textbook where you're going to have to read for information. Later in your life, believe it or not, the majority of the reading that you will do in your working career is reading for information. So, for example, I'm going to work for BLN, and I'm going to be up on the mountain because I hate to be inside of an office. Well, guess what? Two things. When you're in the office, you're going to be reading reports. When you're in the field, you're going to be reading maps, either on your phone or elsewhere. Well, what is that? Reading for information. So there's a reason why. I'm taking a few seconds here to just explain. There's a reason why this kind of study is important. So don't just go, oh, seriously, this is kind of important. We're going to look at two expository texts. I'm with you on 742. We're going to look at the case study, Careers in Robotics is what it's called. And then we're going to look at a news article as well, all right? Now, our reading skill will be to paraphrase a text to discover the main idea. Read it with me. Paraphrasing a text, putting the ideas into your own words, helps you determine the central idea, what we will call the thesis, of course, in our own writing, right? Clearly stating information allows you to judge the significance of ideas in order to decide which are most important. Paraphrasing ideas will also enable you to move more easily find connections between those ideas and other sources. We call that learning, don't we? The ability to connect new information to old information that deal with related topics. You've got a checklist here that's going to help you from paraphrasing to determine first source, central ideas, similar or related ideas. We're going to be connecting these ideas from two different sources. We do have some content area vocabulary as well that you want to look at before we get into the actual study of the text. If you'll look with me on 743, the case study features that we're going to be looking at, explanation of what is being studied and why, facts, examples, quotations, text written for a specific audience. Let's read together, shall we? This is, by the way, the NASA Robotic Education Project, okay? Careers in Robotics, a case study. Think you'll never use high school math? Think again. Jill Jones and Matt Zucker may seem like regular guys just out of college, but they have one of the coolest jobs around. They are both software engineers for a company that makes underwater robots, otherwise known as autonomous underwater vehicles, AUVs. AUVs are small unmanned submarines that use onboard artificial intelligence to complete survey tasks with little or no human supervision. So put this in your notes right away. This is going to be about AI, artificial intelligence. By the way, I've often said this to freshmen when we're studying a text like this. So you like to play video games, but what's to keep you from making video games? Because somebody made that game, somebody designed that game. And by the way, artificial intelligence, we know, is going to play a huge role in the future of gaming, no question. So, for some of you who love gaming, you may say, you know what, I like it so much, but I would love to be able to have the freedom to make my own games, which obviously requires me to know a lot of math and science. I'm going to go to college to major in that, study in that. Let's keep going. Although Matt and Gil do the same job now, the differences in how they got there shows there really is no single path to robotics. By the way, paraphrasing, notice it says at the side there, paraphrasing these first two paragraphs will help you to determine the main idea of the case study. And then a heading. Always pay attention to the headings, getting there. I was a classic underachiever in high school, says Matt. I got into college by the skin of my teeth. Once I got into college, though, I realized I wanted to focus on my interests. Studying something I liked really made it all worthwhile. In college, at Vassar, Matt took his interests in biology and computers even further. He took classes in psychology, philosophy, anthropology, human brain and behavior, and artificial intelligence to work his way to a degree in cognitive science. His main interest? Helping robots and computers learn complex behaviors. Gill, on the other hand, was a good student in high school, but didn't start out in robotics either. He was more interested in political science. At Swarthmore College, he was inspired by computer science. Quote, I wanted to focus on artificial intelligence. I took an artificial intelligence class where we started playing with toy robots using handy boards and sensors, end quote. Gill really got interested in robotics through AAAI robotics competitions. Imagine creating a robot that can serve hors d'oeuvres. And when he graduated with a degree in computer science, a lot of his experience was with robots. By the way, again, notice on 743, the little box there, paraphrasing the 3 paragraphs in this section will clarify how the subjects of the case study, Matt and Gill, got their starts in robotics. By the way, so you can just put it in your notes right now, we could do a real quick comparative observation. What's different between the way that Matt, the underachiever in high school, and Gill, the really great student in high school, what's different about the ways they came to their interest and study in robotics, right? Some of the 2 different paths, quite radically different, yet they both end up at the same place, which a 3B observation suggests that a lot of times what you start out majoring in college is not what you grow up to do. A lot of times the things you're interested in right now as a freshman will not be what you're interested in 5 years, but then you already know that because 5 years ago, if you were a 9th grader, you were in 4th grade. And your interests then are not your interests now. Do you know what I'm saying? So as you start to think about your future, you have to keep in mind, there's nothing set in stone. No, I am definitely going to go into medicine. Well, yeah, I mean, that's cool and everything, but you may change your mind. You know what I'm saying? I mean, a guy starts out in political science and ends up in robotics and AI. Fascinating. The bottom line, both Gill and Matt agree, is that you don't have to go to engineering school. Liberal arts colleges and liberal arts universities and colleges will also give you the skills you need to do robotics if you're interested in a lot of things. Physics, math, science, engineering, communications, and others. You'll do well. I'm on page 744. Landing the job. Both Gill and Matt did summer internships during college that provided them with work experience and an idea of how to get a job in robotics. During one summer, Gill worked for the Naval Research Laboratory doing software artificial intelligence research, and then after graduating spent the summer preparing for another AAAI competition. When one of his friends got a job at a robotics company, Gill learned about the company and then applied to be a software engineer. Matt got an internship at the same company during the summer between his junior and senior years and was then offered a job following graduation. What's their best advice for getting internships and jobs? Perseverance. I would write that down. Now, I mean, we've been saying that in any number of ways. I mean, think about our message from Carry Your Own Skis, right? Perseverance. It means don't give up. Keep going, keep going. Don't give up on your dreams, right? Perseverance. Just find someone who works in robotics and ask them for advice, says Matt. Gill adds, sometimes it's difficult to get in, but keep trying. Think about doing an internship for free. Often internships are the first step through the door. The next heading, research, programming, and cruising, question mark. One of the great things about this job is the variety. Sometimes they spend all day reading up on computers, on robotics research. Sometimes they spend all day in front of a computer, and sometimes they spend all day hanging out on a boat testing the robot in the ocean. You're making something that has a purpose, something that's part of a bigger project, says Gill. You get to see if what you did worked. Of course, that means you're entirely responsible. Another perk, according to Matt, is that you, quote, you usually get to learn something big and new every few weeks, end quote. One warning, pay attention in high school math classes. You'll use trigonometry like crazy. Final heading, next steps, and notice this, the note here. The final paragraph of the text often contains key details. Paraphrasing will ensure you understand these points. Both Matt and Gill plan on going back to school sometime to do graduate work. Matt wants to study computer science, focusing on computer graphics and computer-human interfaces. Eventually, he wants to be a professor. Gill plans to go back to school, specifically in robotics. He finds underwater robotics exciting because it requires autonomy, but there are a lot of other cool areas of robotics he'd like to explore. The draw for both of them is that robotics is a quickly changing and very open field. As they point out, quote, you can do new stuff in any of the related areas, and that's exciting, end quote. I actually have a student who has now just graduated, an old student who graduated just recently from university, and she took her degree in artificial intelligence and cognitive science because she's very interested in the gaming world, but she's very interested in the marketing in the gaming world. In other words, how do you find out who plays what games and why that's important? So here's some introductory materials for you. Maybe this will spur you to begin to think a little bit about, a little outside the box, maybe even about what you're going to maybe do someday in your studies. Thank you.